Good morning, Scott.
Morning.
Okay, everybody, I think we'll go ahead and get ready while more people keep joining us. But my name is Christina Baxter. I want to thank all of you for joining us this morning, evening, afternoon, depending upon where in the world you are. There's people from all kinds of places joining us today. So we will go through and do this webinar. As with all webinars that we do, this is being recorded. So for those of you that are in the middle of the night right now, thank you for joining, but we also understand that you probably want to watch it again later. So we will have that recorded and you'll be able to get access to that through the ProEngine team. I'm going to pass over to Scott for the ProEngine introductions and just reference my Christina Baxter, and I'm from Emergency Response Tips.
I'm Scott Hartley. I'm from ProEngine, and really the purpose of these webinars is to provide some education. We try to do about 4 a year and have information that's hopefully relevant to the community from an educational standpoint. So I think today's topic is hopefully very interesting with a number of large-scale events, especially coming to the United States in the near future. So hopefully this will be beneficial to everyone.
And the dog just joined the webinar.
Rico.
Perfect. Okay, I'm going to turn off the camera now and we'll go from there. Okay, well, thank you guys for joining us. And first off, I just wanted to talk about what is it that we're talking about when we talk about a special security event. So in the United States, we have oftentimes called National Special Security Events, or NNSEs. In Canada, you might call them a major event or a major international event. Every one of us calls them different things, but they all have something in common. They're highly visible and they're very high profile. And when you get to these events that are highly visible and high profile, it increases not only your potential target for terrorism, criminal activity, or other disruptions, and all of that's really going to depend upon who's there, okay? Who are those anticipated attendees? Are they high profile? Is it just a large number? Is it a major concert? What's the significance of the event? So political conventions, obviously in the United States especially, we have a little bit of disruptions with those. Or are there historical threats that have been part of that? So for instance, Boston Marathon, there's historical precedents. That means you've got to increase the security for that event in the future as well, just because it becomes another high profile target. And so that's the kind of event we're talking about. There are events all over the world every day that meet this type of capability threat. And so we wanted to go through and talk a little bit about these. And for us, when we start talking about these things, there's 4 different areas you really need to focus on. So unified command, CBRN readiness, infrastructure hardening, and then the airspace and perimeter control. Obviously, we're talking about detection. So we'll kind of leave the unified command to all of you in the airspace and perimeter control. And then we're going to focus in today on CBRN readiness and the infrastructure hardening components. Now, one of the topics that we will talk about is the Joint Hazard Assessment Team. In that case, the JHAP planning overview. And a lot of these teams, remember, the JHAP process is not a replacement for your hazmat team. And it's not meant to be a full hazmat team. I see we have Dion on here, and she's done a lot of these for FBI over the years. And so one of the things that you have to think about here is how are you going to integrate all these people together? And frankly, when we get down to this, and you're inside of a major event, and you're in that inner circle or inner cordon, we want to make sure that we don't have a giant full-scale hazmat team set up and moving, or set up full bomb squad, and creating more of a distraction than a help. And so in this case, we have these smaller coordinated teams of the different elements. And what we're focusing on here is, can we either adjudicate a threat quickly, or do we need to elevate it to a full response? And those types of things are what the JHAT does. A quick assessment of an event or a device or anything that's out of the normal. And they come in and say, yeah, we need to elevate this to the bomb squad, to the hazmat team, to whatever we need to elevate it to. Or we can adjudicate it right here. So a JHAT team would not carry all of the detection equipment that a regular hazmat or bomb squad team would carry, but they carry a very small select subset which will allow them to get a broad detection scheme, but not all the answers. Big thing here is to remember that a JHAT does include your partners from the local, the state, and the federal level across all elements. If you want more information on JHAT, because this is not what this class is about, please feel free, reach out to the Hazard 3 team through Safeware, and you can get all the JHAT courses you want taught by former FBI folks like Dion and Kevin. So we'll leave that at that. I want to talk a little bit about where that urgent priority is today. There has been a lot of change in the threat for CBRN in the last, say, 6 months. And reality is, in the last month alone, that change has been pretty dynamic. Now, as I go through these, I just want you to think of them in perspective. Urgent priority is something that I feel could happen today. You must be ready and prepared right now. The near-term priority are those things that are easily accessible to some extent, but also are things that we are worried about, and you should be actively engaged in learning and making sure you're prepared for this. And then that prepare priority are those ones that we think are probably longer term, not things that I'm thinking are going to happen today if an event were going on today, but depending upon where you are in the world, that threat can be much higher. So I know we have some of our friends from Czech on here today. Some of these are higher threats to you than would be to us in the United States because we don't have those things readily available. So I'm going to go through some on the urgent priority as our main threshold here. So in terms of toxic industrial chemicals, today, where we see the biggest threat, especially as it comes to a special security event, are binary devices. So a device where they have taken a couple of different chemicals and they have mixed them together to create a toxic industrial threat. So probably the number one talked about would be a hydrogen cyanide device. And with that, you would have sodium or potassium cyanide salt mixed with something like an acid. When you add those two together, you get hydrogen cyanide gas, which comes out. That creates quite a problem, as you can imagine. The other binary devices that they talk about a lot are hydrogen sulfide and phosphine. The one that's most likely to occur out of all of them is actually chlorine, mainly because of pool chemical supplies and things making chlorine production quite easily attainable for anybody. And so the different geometries of devices that we see today have changed tremendously as well, going from the original Moog Talker type design where you had a lot of your different elements within an outer container, forcing that mixing and getting a more complete mix, to today where you might see these in a PVC pipe looking like a pipe bomb, where it can create the same hazard, not as high of a amount usually. Corrosive attacks is one of the others that we worry about, and mainly because you can get different materials in and around. And so corrosives are any of the acids or the bases that could be a problem. Traditionally, we see more in terms of sulfuric acid, maybe some nitric acid or hydrochloric, depending upon where you are. And then we also see it in terms of sodium hydroxide. And we have seen a little bit with bleach and ammonia, but not as intensive as we see the others. The irritants, or the homemade irritants, mostly, which would be making your homemade pepper sprays and things. If we go back just 10 years, we used to see more of the pepper sprays that you could buy and get in the field. If we go back 5 years, we started seeing more of the bear sprays and things of that nature. If we just go to today, we really see homemade pepper sprays and things. The big difference here is that they're oil-based. And so they're mixed in with things like having vegetable oil or olive oil as the main ingredient to make sure that it sticks to the person. In terms of pharmaceutical-based agents, obviously fentanyl-related substances are out there in the United States, especially in large quantity, making them a big threat. As we go into the biologicals, this is where we've seen a lot of change in the last month even. So if you start looking at some of the new literature that came out recently, so February 10th, there was a new method out there for the production and dissemination of botulinum, and another one for oleander. Those are very problematic because they are very targeted and easily attainable. Ricin, nicotine, also big targets for us here in the United States. Mainly, again, easy access, easy ways to produce the materials. And if you start looking at the new Invade magazine that came out on 10 February, that gave a lot of detail on how to produce and how to disseminate some of these things. Incendiary devices, so Molotov cocktails and napalm-like devices. A lot of this is more about going to that napalm-like device that sticks and causes more of a problem, increases the temperature up to 2,000 degrees in some of these. So where a Molotov cocktail, you would end up getting a surface burn on an officer, a napalm-like device is really a 3rd or 4th degree burn going all the way through the clothing, through the skin, and down into the muscle and tissue. And then, of course, we saw that again this week. Homemade explosives are still out there. TATP has made a comeback. A lot of that has to do with accessibility of materials. But reality is most of the different methods out there talk about the use of chlorates and perchlorates, which does create a little bit of a problem because most of our detection technologies out there don't target chlorates and perchlorates. There are colorimetric tools that are readily accessible, are inexpensive, that detect these very well. And so if you're doing your planning, and explosive side is one of those things you need to be planning for, we need to make sure that the technologies we're choosing are able to detect these different things. Now, in terms of that near-term priority, I do want to touch on a couple of things here, mainly in terms of traditional chemical warfare agents, sulfur mustard, because it can be made so easily with off-the-shelf components as well as materials that are readily accessible. Obviously, we do elevate the A-series or Novichoks, mainly because of depending upon where you're on the world and who you've gotten mad recently, those are high threat materials. In terms of the toxic industrials, their use of pesticides offensively again. Now, the good news is in a lot of places around the world, the pesticides have different materials like vomiting agents added so that if you do get into contact with these, you tend to throw up a lot of the material, which is nice. And then, of course, the explosives here as well. We are seeing a lot of metal enhancements again. So adding of aluminum, adding of sulfur and things to the explosives to give it more of a bang for their buck, literally. Now, as we get into these bottom ones, it doesn't mean that they're not a high threat. Radiation continues to be a problem. We continue to have radioactive sources roaming around out there that shouldn't be. Now, are they just lost? Have they been misplaced? Or have they been stolen for nefarious purposes? We don't know. But they are things that you must be monitoring for. So I'm going to leave the emerging threat here. If you have further questions on these things, please feel free to reach out. And I'm going to go in now onto the CBRN readiness side of it. So just using a generic stadium here in its area. So this is nothing to say anything about the threat of this stadium, but just because I have good pictures of it. So what we're looking for here is a layered detection approach. As we come into any of the stadiums or different venues that would be used, you want to have a detection architecture that allows you to have multiple layers because different technologies are going to fit different areas. So for example, in this one, that inner ring where it's red, that's really where we've closed off accessibility of different materials. So pre-screening of that space and getting it open and ready for the event should have minimized a lot of the threat materials, which means continuous assessments by a very focused team is a suitable approach in there. Whereas you come out to that yellow ring or the middle ring and you've got all your attendees screening and things coming in there, that's where in the yellow ring and the blue ring, we have a much broader threat. Mainly people are coming from their vehicles. People are coming from subway stations, train stations, buses, where they could have carried anything they want. Until they get into these gated entrances, those types of materials are in game. So incendiary devices, the napalm-like devices, your binary devices, all of those are easily deployed in these areas because there's limited security there. And that's where we have to start paying attention. And in this outer ring, we also are going to have things like the hazmat team staging, the bomb squad team staging. Instead of having them all the way inside the venue, generally having them in the outer ring with all of their extra access and capabilities is where we need it. But also provides us with a place where we can have some wide area monitoring going on to make sure that nothing from outside the perimeter is becoming a problem inside the perimeter. So based upon each of these things, the highest threat areas end up being those outer rings where you have that complex pedestrian and vehicle flow. Because if you've done it properly, you've already closed off this inner ring. And so now we're looking at a smaller targeted set of threats inside. So if we're in the outer ring, we really have remote monitoring for radiological and chemical types of materials out here. Because all of that is things that people can bring in anything they want in their vehicles. They're parking in an outer lot. So continuous monitoring remote capabilities are really critical out in this outer ring. When we come into that next ring, it's going to be the remote monitoring still, but you're also going to have to do point source testing. So in this case, having sensors set up at each of these gate points where people start to flow through, you have a slower flow of people. You're having people out in the blue area that are gathering, and you're starting to get lines of people here in the yellow area. One of the things that you have to consider here is your point source detection for explosives. This is where you may use some of your technologies for swabbing hands, for measuring different containers, if you're allowing containers to come in, which is generally a bad idea. But if you are allowing it, then are you using Raman or infrared to be able to look at some of those materials? Are you using ion mobility for explosives detection for point source? And if so, is that targeting all the threats of interest? Or do you need to add in some colorimetric or other technologies to measure the inorganic explosives or the TATP-like explosives that are in vogue right now? And then as we get inside, we've done that whole protection of the area. So now we're really focused in, if it's an outdoor stadium, UAV delivered threats, high concentration, low volume threats that may have gone in on a person's body, binary threats, because we often allow powders to come in. And so if the solid made it in and they just have to use an acid from inside, whether it be a soda or it be a lemonade or something of that nature, they can create their binary threats, not as effective, but still problematic. And then of course, cleaning products that are still in the space. And most importantly, the insider threat. When you start thinking about the fact that you've cleared this space of what you consider to be the most threats, you still have to remember that as material was brought in and out of this stadium, while most people have been cleared for backgrounds and other things, we do have to consider that there is the insider threat, and that will always remain, no matter where we are, whether it's airports, it's stadiums, it's concert halls. There will always be those groups that have to bring in beverages, that have to bring in materials, and all of that is getting in and out around your testing. I'm going to turn it over to Scott now for a little bit.
So in regards to again, this whole concept of survivability onion or multiple layers in there, the central most location is obviously the most important, but in order for things to get on the inside, they have to come through the outside. So our approach when we want to do it, especially from a detection standpoint, is trying to detect those materials as far out as possible, as we can get closer to keep them from getting into the inside. Now, before an event starts, we do usually a very thorough scan of it, and then we restrict motion of things inside until the event really opens up. And then as we do allow the event to open up, we want to try to screen those people coming in. But once the inside has been screened, what we need to do then is start detecting from the outside. And in that case, what we want to do is to take those points at which there should be a little bit longer dwell time, where those, all the things need to come through a centralized point. So it would be an entrance of a vehicle, or in the walking of the actual people going to the event as they're going through their screening. Both of those areas represent good points for detection because of the fact that, one, they're a constant point where everyone's going through, so there's only a limited number of entrances, so all vehicles have to go through there. So we want to take advantage of that in order to detect and to be able to sense. And then on the same point, in the yellow area, which is where the screening part is, we want to take advantage of the fact that they're going through metal detectors and screening points and a central location where they're walking through, and they have to be slowed down in order for that process to check their tickets and to go through that screening, to take advantage of those points. So in the case of detection, one of the things you do need is you do need some time. If someone just walking really fast or going really fast by you, that can actually be, it's hard to detect those things, especially with what's being brought in by an individual. So taking advantage of dwell time with that will be important. We'll kind of talk a little bit more about response time and different technologies a little bit later in there. Probably your area of most vulnerability from the ability to attack is the security screening application. So for any of you who have been in a large-scale event, even just an NFL game, a lot of times people are tailgating and they like to bring drinks, but they don't allow those drinks in. And so what people do is they just throw their bottles down on the side, right where everyone's walking through. And the problem with that is if you put a binary agent in the same thing, it's not going to really attract a lot of attention unless it's off-gassing some sort of cloud or other things like that. But that's a perfect place for someone to put a purposeful release of an agent and get it in direct contact with people that are standing still waiting in line and not really drawing attention. So that's probably one of the biggest vulnerability areas for you as an individual attending is during that time period with it. Now, usually try to also restrict cars from getting into those locations a little bit further and having different areas with it. But once you get into that inner ring, then you're usually a lot more protected from the standpoint of you've gone through multiple screening efforts with that. So as far as kind of the next slide, we'll kind of talk through some of the tools that we have available for us as far as how we monitor with this. Is one of the key aspects of it is how do you holistically do a response where you now have multiple detection points throughout the venue, and you're wanting to make sure that you're sharing or collecting of that data. And that's a second point that we are kind of going to discuss today. And we have a whole section around that, which is just what we call Pro-Engine Shield, which is just a way of bringing multiple detectors together. They aren't Pro-Engine detectors in all the cases. Hopefully there's at least some of them, but what you can do is have multiple independent detection systems from multiple manufacturers, all reporting together in a single point to help with monitoring and alerts and response. And that's the second thing with this. You have all these points throughout a venue. You need some place where you can monitor and control and use that to properly respond to an event, because you obviously, in the case of a JHAT, you don't usually have resources where you can put at least one person at every single location. You have to be able to respond appropriately and bring the right equipment to that. So that's where the overall monitoring also becomes an important aspect of a holistic response. Next slide, please. So again, this is just a scenario kind of showing you a hypothetical with there. So it kind of ties in with what we discussed before. You kind of have a couple major choke points where people are coming in, and they usually have some sort of residence time in there. So those are rail stations, there's vehicle entrance points, as well as the ticketing locations with that. In some venues, they just have one central location where most people can get through unless you're like a VIP. But in those cases, that's where the sweet spots are for monitoring of detection. So on the outside, having both radiation and chemical detection with some biological. Inside of those, the same thing with those. But people might be able to bring those into the points, and then just the ability to then collect and analyze those things together as a holistic. You can go to the next slide. Now, when we talk about detection capabilities, one of the things is our nomenclature and how we tend to discuss those. So we kind of break detection down into two major categories of detection. So there's trace detection and bulk detection with there. Both have an importance and both are needed as part of a detection profile. The difference between these is with trace detection, what you're really trying to do is something that's very fast, almost continuously responding. It's very easy to handle. It can be worn. It can also, in the case of a J-hat scenario, you want to wear something that's not going to attract attention to you overly. So if you are out there holding this heavy or this detector with a nozzle on it or other things like that, you're going to scare people. So what you tend to want to do is use wearable technologies that you can have on your vest or whatever that don't really attract attention. Yeah, they see you're carrying something, but they don't necessarily know what you're doing. And most people aren't even going to pay attention to you. So you can kind of blend in and you aren't going to cause attention to people with that. In these cases, what's really important is that they're very fast responding and they're very sensitive for what we're doing. Now, you can't always use them to 100% validate, and that's where the bulk detection standpoint of, but really with the J-hat, it's to identify, collect, respond, figure out classes of materials, and then figure out what is needed to be, how you take the information that you've been able to glean from it and then use that appropriately to respond. And always what we want to do is to do some verification, and that's where your bulk detection methods go. So your Ramons, your FTIRs, your GC mass specs, high pressure mass specs, those sort of instruments are very good for being able to take a sample and run a scan and determine what they are. But they tend to be a lot more bulky, they're very costly, so you usually want to try to bring the sample to those in order to do the validation and the detect to identify with there. So both types of detection technologies are important and they're needed as part of a holistic response. Next slide.
Yeah, and remember that, and the bulk detection technologies are usually on scene, but they're outside with the hazmat team that may be called in if the decision is to elevate an event versus adjudicate.
Yes, exactly. So as far as recommended equipment that will respond to a lot of the threats we were talking about, and over this next kind of slides we'll parse this out, are your PID, so your multi-gas monitor, a flame spectroscopy device, and then as well as a variety of papers. So what the papers will help you with is detecting if you have a corrosive threat, if you have an oxidizer threat, the nature of the type of threat as far as its pH, all that's important information. The PIDs will be very quickly for letting you know if you're dealing with something that, is there oxygen deprivation, is carbon monoxide, is there certain of these binary materials associated with that. The challenge with them is they are very cross-sensitive to a variety of different materials. So lots of things can trigger them off, and you may not necessarily, what they're triggering on may not necessarily be the material that you're actually seeing. They're cross-sensitive. So that's an advantage of now using the AP4C in tandem with them, is that you're going to get classes of materials. In many cases, the AP4C is more sensitive as far as its trigger level. So it triggers all the way down to like 1 microgram per meter cubed with it. But in tandem of both of those technologies put together, in tandem with your papers, you can identify pretty much everything that we're going to be on that list with it. Additional materials that are very helpful to have with you are small thermal imaging cameras. So that will help you identify, are you dealing with something that's exothermic or endothermic with it, because it'll have a difference in response to the ambient temperature, allow you to see certain things as far as the thermal signature that you otherwise wouldn't be able to see. And then as well as an emergency decon kit. So if you find something, you can quickly, or if you or yourself are exposed, you need to bring that sample out of there to be able to do that. And then in addition, obviously having a radiation, being able to have a PRD on you to identify if there are any radiation threats in the close proximity. So between all that, it's kind of giving you your full ambience of all your type of threats you could kind of see in there. Next slide. So what this is just a quick video, since some people aren't necessarily familiar with what flame spectroscopy does and why it's kind of an important, nice tool to have. So in this case, what we do is we have a flame inside of the machine. And so what that flame does is it's able to excite incoming materials. And what happens is those materials go to an excited state, and when they reach back to the ground state, they produce emissions specific to that element and that element only. So it's similar to how fireworks work with known metals, getting a certain color response. So what we're doing is we're constantly pulling materials through there. We have a pre-burner, which is what you're seeing there, because we have a flame. You could be operating in a flammable environment. It keeps the flame from propagating outside of the device. And then we're pulling materials constantly through there. One additional thing that you're seeing in there is there's no filter ahead of there. So aerosolized threats, things that are solids that have been aerosolized or purposely released, those will also get a response through the detector. So it's kind of handling your vapors. You can handle vapors coming off of liquids and other things like that, and you're constantly pulling those through. So what we're doing is we're exposing it, then we're collecting the optical information coming from there. So what we're doing is taking a series of lenses, focusing it on a CMOS sensor. And what that CMOS sensor does is it allows us to collect a whole bunch of spectral information, and then we're comparing it against the fingerprints of the different elements that we're most concerned with trying to see. And then once we see those, we're able to quantify their strength if we're seeing those actual elements or those responses in there. So it's a very fast responding, and since we aren't using an electrochemical response, we're working on light, and we have light in darkness. We're able to see down to very, very low concentrations, again, as far as low as 1 microgram per meter cubed, which is in the single parts per billion range on there. The next slide.
So I wanted to kind of show here why we chose the detectors we chose. Okay, so if I just look at these priority threats right now, so the binary devices, as we said, were chlorine, hydrogen cyanide, hydrogen sulfide, and phosphine, but also some of those household cleaners, things that can be made from household cleaners by mistake or intentionally. So ammonia on its own, ammonia acetate, when you start mixing it with vinegar, ammonia hydroxide mixture, chloramine, as well as chlorine. Pharmaceutical-based agents, because they're just everywhere. So we just put down fentanyl, but any of the derivatives. Chemical warfare agents, remember, these are the things, very low volume, but high threat that we would expect in these types of events. So A series, sarin, sulfur mustard, and VX. And then, of course, the chemical irritants that are most likely. So CN and CS, because of them being in commercially available products. Capsaicin, because that's in most of the homemades. And then chloropicrin, because everybody just loves it lately. So that's one of the ones that we're worried about. So when I come in and say my first detector is my 5-gas, if I look at this chart, I can see that in the areas where it's green, it can measure that material. So for instance, on the first column here, first row with chlorine, the hydrogen sulfide sensor is cross-sensitive to chlorine, but it's going to take me about 30 seconds to see that. For hydrogen cyanide, the CO sensor is cross-sensitive, so I'm going to see hydrogen cyanide here. So you're seeing the cross-sensitivities coming into play here for you, which is going to help us figure out those binary devices pretty nicely. It also helps us with some of the household cleaners. Okay, so we end up getting ammonia. We would get some of the ammonia coming off of ammonia acetate and ammonia hydrogen peroxide mixtures. And then, of course, the chlorine again, hydrogen sulfide. And then the PID will go off for different chemical warfare agents. You won't be able to tell what it is, but at least you'll have a PID response to those once they reach a certain level. Now we could, well, the first thing I looked at really was adding in some specific extra electrochemical cells. So these are just some of the different electrochemical cells. And by adding in these, we actually didn't get much benefit. So there were a whole lot of different cells, from hydrogen chloride to some more chlorine specific, or even hydrogen cyanide, ammonia. But as you can see, by adding these, the only benefit they really provided was potential in the yellow, because those are things that we think will set it off, but not necessarily known or calibrated. That would help us with chloramine. But we can already get that with other approaches. So adding these additional E cells didn't help us. But when we added in the AP4C, it started bringing in a much more well-rounded approach. And so just by doing that, we ended up getting an answer for all of the different high priority threats that we had. So when you start adding just a 5-gas in the AP4C, all of these different priority threats are now attainable. Now we do have to also remember about time. So I'm going to start this, and I want you to think about this as we go. So remember, the AP4C is measuring 12 times per second. The PID is measuring 1 to 2 times per second. And then you're starting to get other things. But in terms of a quick adjudication of a scene, time becomes critical. So here's our 0.1 seconds. So we're less than 10 seconds, and our PID, our papers, and our AP4C have all given us answers. We have to wait till 10 to 15 seconds before we hear from our CO and our flammability, so oxygen flammability. We're going to wait till 30 seconds before we start seeing our CO and H2S. That starts to be a long time. If you start thinking about the speed at which you move when you're using your detectors, I think everybody needs to stop and slow down and make sure that they understand what their sensor's telling them when. Yes, your sensor may have been going off, but the data would not be quantitative until it reaches its T90. Okay, so that 90% of its full signal, you can start using it from a calculation standpoint, which we're going to then use to tell us about exposure and where it makes a difference, where it really matters. And so you can see that at 35 seconds, our hydrogen sulfide went off, but we have to wait much longer for our ammonia and others. And of course, I don't wait long enough for all of them to go off. But if we waited, we could start getting out here and getting our gas phase FTIR, any of these other things. They take longer. This one can provide us a lot more information, great tool, but for that very fast adjudication, it's not the tool we're looking for. So when I start looking at that optimized solution, here are our different threat materials that we had determined. And now we can actually look at it and say, for chlorine, we're going to use our hydrogen sulfide cross sensitivity. For hydrogen cyanide, we have two methods. We have the nitrogen channel on AP4C, and we have the CO cross sensitivity. For hydrogen sulfide, we'll see the sulfur channel, CO cross sensitivity, and our hydrogen sulfide. And then for phosphine, we'll see our phosphorus channel, the PID, the CO sensor cross sensitive, and the H2S cross sensitive. As we get to our household cleaners, our ammonia will go off for the AP4C, the PID. Our ammonia acetate, ammonia hydrogen peroxide will go off for the AP4C and potentially the PID, depending upon how much degradation of the material we have. The chloramine will potentially go off on both. And then hydrogen sulfide, again, cross-sensitive. When we get to those things like fentanyl and some of our other high-threat materials, we're going to use our AP4C alone. And then sarin, sulfur mustard, and BX, the AP4C and the PID together. On the CN, chloracetophenone, PID. And then for all the others, we're going to use our AP4C. And so you can quickly see that you can now start adjudicating what types of things you have there or rule out what you have there pretty quickly by having a small subset of detectors that you're bringing downrange for that first JHAT mission, and then saving our other detectors for when we escalate the scene and call in the hazmat team or call in the bomb squad. So just by putting those two things together, we've now covered our threat matrix. Now, I'm going to go from the front end CBRN readiness and now go into infrastructure hardening a little bit, because depending upon what type of facility we're responding to and the age of that facility, there's a lot we can do with infrastructure hardening as well. So a couple of things to think about: early detection and alert logic. How can we integrate some of this with an HVAC system? Can we use airflow controls to protect the venue? And then if we're going to do all of this, how do we manage that cybersecurity and resilience of the system? Because that becomes critical. So just looking at this from the very beginning, if I'm looking at a ventilation system, I want to first go to the outdoor air intakes and make sure that I have technology that can detect anything coming from the outside in, the main ducts within the system, and then any areas where you have a high risk, so crowd density areas, or it could be VIP areas where you're going to put specific VIPs and have them protected. We also need to make sure that there's a software aggregator in place. How do we take the data that those sensors are seeing and let the system make a decision. Without some type of decision support logic embedded within it, you can't actually go forward and have it do anything. Everything's going to have a human in the loop having to make those decisions. And so what we want to have is something where we can put that data together, have it be correlated, and have that filter the alarm, saying, you know what, if just the CO sensor is going off and it's just going off at this level, then it may be a valid alarm, but it's not enough to trigger a threat. Whereas we can have some others and say, if these two things aren't together, then it's a false alarm, treat it accordingly until investigation tells you otherwise. Then you have that control logic. The control logic is what's going to help the ventilation system turn off, turn on, turn damper different areas. It's all going to be based upon whether that threat is coming from the outside or coming from the inside. And as we get to the newer systems, now, first time I tried to do this with a system was, oh God, years ago. And we were dealing with a very high profile US building, which had at least 5 separate ventilation systems from different manufacturers, different types. And we were trying to figure out how can we get them to talk to one another to increase the protection of the overall building. And it takes a lot, but today's systems are much smarter. Scott, I'm gonna have you do this one.
Yes. So an additional thing, an additional complexity is how do you do detection for both chemical and biological materials associated with it? So on that earlier slide where we showed the HVAC system outside, that's an AP4CF. So it's running 24/7. It only needs to be a little attention to it every month. In the case of what do you do when you actually need biological simultaneous as well? And we have a solution for that. So the same flame spectroscopy process that we talked about earlier can be utilized, and we added additional channels of sodium, potassium, and calcium, and it allows us to identify biological materials as well with it. So in this case, what we're doing is we know the specific ratios of sodium, potassium, and calcium when they come in contact with biological materials. So there is a little bit of a different response depending if you're dealing with a spore versus a virus or a bacteria that's associated with it. And plus you have differences in environmental situations based upon time of year. For example, the amount of biologicals are different in the amount of summer as they are in winter with it, plus just different locations. So if your detector, for example, is close to some sort of saltwater location, or saltwater can be brought to it through different fog layers, that impacts the environment. And so what we recently introduced is a Gen 2 version of the AP4C VB, which has a learning algorithm in it that takes in consideration the environment, establishes a baseline. And then what we're doing is establishing that, using that baseline, and then using machine learning algorithms to trigger off of the device. So as part of a holistic response for fixed infrastructure with it, you can use this detector system to now not only flag on the chemical materials that we had discussed earlier, but now add biologicals in tandem with that. So the system is designed to also work with other samplers. So you can actually take a trigger, a sample of either a liquid or a dry sample, depending on your preference with that. Or you could also tie it into a building management system or into the ProEngine Shield system to do that monitoring on your behalf for this infrastructure of various types. So again, going back to the other security event applications, you could put these on a golf cart or put them attached to a vehicle, for example, that moves around, and you can do the sensing in those key areas. And in some cases, you may need to move as that venue changes. As you change from vehicles coming in to then pedestrians primarily going to then monitoring the overall facility, then the exterior of it. Then if there's a desire to move that around, this application would work perfect for that, and it's about the size of a shoebox.
Okay, so I talked a little bit about integration of some of the protocols. So in order to get this to work properly, you've got to kind of go through and say, what are the scenarios that could happen? So I was saying, to keep it as simple as possible, I just said, hey, it's an external or an internal event. And from that, you actually make your standard building protocols that go with the softwares and allow it to have commands. So let's start off on the left-hand side with an external event. So the first thing I'd want to do, if it was an external event coming into the facility, we want to close in those outdoor air things. So close the dampers, seal the fresh air intakes, isolate from the environment. The second thing, switch the system to recirculate. So it's closed any of the air coming from the outside, but now it's also just recirculating what's inside. Overpressurize specific areas. So if you have an area where you may have your dignitaries or high profile types of areas, you might want to overpressurize those spaces to ensure that they have a positive pressure to minimize any toxic gas getting in. And then, of course, stop any of the exhaust fans to going to the outside. So powering down a lot of those and just trying to make sure there's no passive influx of materials as well. And so that's just one idea of what you could do of having a standard protocol where instead of having the system design and change for comfort characteristics like temperature, humidity, CO2 concentrations, instead now we're saying we're going to override comfort and we're going to go from an external CBRN scenario. Now, if we had an internal CBRN event, meaning something got into the building and we were able to, and they were able to release it inside, now it takes it a little bit differently because you've got to identify what the area is and then say, how are we going to shut down a specific area? So in that case, all of your ventilation systems have zones. Those zones are usually accessible and able to be turned on and turned off independently, which allows you to do a lot of work in terms of changing your different flow rates and where things will move. For example, when we were studying some of this, we had a building where we actually wanted to get material to move in different directions. And so we just changed the temperatures on interior and exterior rooms to push the chemical based upon temperature gradients. And there's all kinds of different things that can occur which allow you to move the chemical based upon the way you need to. Reality is you're trying to move the chemical away from the areas that you're going to direct evacuations. Now we have to remember all of these things are great until the event is affecting multiple areas. Now, how are you going to manage that? And having just these protocols are great for a single incident, not so great when it gets to a multi-layered attack. So overpressurizing, again, the safe zones, making sure that you do have safe areas and that they're overpressurized, and hopefully, if possible, having some areas where you might have a higher grade ventilation HEPA filters with CBRN canisters as well. And so a couple of the countries that we work closely with, I know a couple of you guys are on here, have different critical facilities that do have this capability for high profile areas where the ventilation system is separate and has a specific CBRN filtering capability as well, which is phenomenal. And that's something that can be added onto newer buildings. It's a much harder retrofit on the old. Now, one of the things that we have to think about, though, is protecting the enclosed venues just by using that airflow control we're talking about. You've really got to think this through a lot about where people would be, what exits they would use, or what exits you would direct them to use. Remember that many people are going to follow the common path that they know. So if somebody is used to always coming in one entrance and you had them park in a different area, they're likely going to exit from the one that they usually use. Okay, and then they're gonna have a harder time outside finding their vehicle. But reality is, in a crisis situation, people are gonna revert to the most common usage they have. You may have evacuation corridors set up and signs set up, but if they don't recognize where that goes, they may not use it unless you have people on scene helping direct them where to go. So as you start designing, as people are doing these different plans, make sure that you have a way that you can have an island mode, an area where you can put people that provides them with that safety, that overpressurizes and potentially has that CBRN type of system. But take advantage of pressure gradients and making sure that you can do that just based upon the ventilation system itself. And then, of course, if you can have a dynamic control of the system, then that's fantastic, especially if you have a remote way of doing that, as long as that remote way is ultra secure. And that's where we get down to that security and resilience. Anytime you start wiring together and using communications in between any of your systems, now you've got to think about what happens when that gets jammed or when somebody overtakes it. And it's going to be all about encryption. It's going to be about ensuring that you have the appropriate tools in place to make sure nobody can get in there. And then also, what are you going to do if there is a loss of communication? Either a complete jamming of the system or a complete shutdown of all communications. Is there a way to shut everything down manually? And do people know what the plan is to do manual shutdowns? Obviously, for many of us that work in older environments and older buildings, the manual shutdown's sometimes the only way. And so people do know that fail-safe. But in some of the newer buildings where everything is meant to be automated in smart buildings, it's harder to start thinking about where those controls are, because they're always made with the assumption that everything's always going to work perfectly. And that's not always the case. So important to do a lot of joint training. And one of the things that I see here as one of the biggest gaps is we may do trainings of the JHAC capability. We may do trainings for our hazmat team. We may do trainings with our bomb squad. We may do joint trainings between the bomb squad, the hazmat team, the fire, the EMS. But oftentimes we forget to involve the facilities personnel and the security personnel from the location itself. They are going to be critical elements to the success of the event. If something were to happen, you need the people that know the building best. That will be the facilities and security people in that facility. So if you're not doing joint training with them now, you need to start, because those people are going to be the change between whether it being an okay response to it being a great response. So Scott, back over to you.
Yes. So one of the challenges with large scale events, or even in certain large scale or even in building materials that we talked about before, is how do you bring all these detectors together into a central place where you can observe and understand what's going on. And so as part of seeing that and just seeing that there weren't a lot of solutions that really did that very well or had proprietary use, and so work with certain types of detectors or were only designed to work with a certain one or two of those, what we've tried to do is develop a system which is designed to work with multiple different types of detectors, and also to be able to display that information in a variety of different forms. So what you see here is just an example of both of multiple technologies that are all linked to a central display that you see in the middle. So in that case, what we have are a couple multi-gas meters. We have the AP4CV. We have a version of our biological, so the VB, and we also have a biological sensing material in tandem with a radiation detector. And all of those are talking to one another, to a screen, and displaying that information. So if any one of those devices reaches an alarm, it'll show up on the screen. It can be easily attacked, and you can also use it to subsequently monitor multiple detectors all at once with that. We also are taking into consideration cybersecurity with that, and so you can monitor it externally in different locations, or you can have it hardwired into central locations if you need to, in order to display. A lot of it just depends on what your desire of it is. But when you talk a number of these systems, and one of the challenges was that the event occurs and then you're done with it, and you may not have another event for a number of years that requires it, or maybe it's just a couple times a year where you have it. So you may not be easy or judicial that you have this set up all the time. So just everything's pre-wired, it's ready to go, and you use it for the thing. In most cases, you're needing something where I could set it up and then tear it down and then bring it to a different event and allow it to be able to do that. So the system's set up to do that, and each location will tend to have a different need, different scenario, different number of entrance points, different types of technology you may need to bring to pot. And so the whole purpose of this is just to provide a means or an option for people to be able to configure it in the way that they want and bring multiple detectors together with it. And so we call it all under a ProEngine Shield. So here's just an example of the software version of it, but what you're seeing here is a detector. You can actually access the detector. So in this case, it's an AP4CV that you're seeing with it, and you're seeing it's triggered on both phosphorus and sulfur. So it's displaying that information real time. You can actually click on it and see the trends over time and see how that's behaving associated with it. And then they have the real-time concentration information that's shown, so you can click on it, see real time, or you can look back on it and see the historical trends for it, which is obviously helpful in the event that you are trying to monitor it or need it for plume monitoring, other things like that, or determining where to respond with it. You also see, you can't really tell in the bottom left-hand corner on that display is the biological index. So this is a BB, and this is shown there. So you're seeing it gives you a bioindex, a bioratio, and the amount of material. And then if it's alarming, so it's reached above the threshold, the ACPLA threshold that's set on the device, it also alarms associated with that. So it's very helpful for you to be able to see and monitor multiple devices. One of the challenges when you do have so many detectors put together is how do I can have too much information. So what you're really wanting to do is alarms and then use that to respond, determine what type of threat you're dealing with, the magnitude of that threat, and then what sort of resources do I need to apply and do so quickly and set up unique for that specific event or facility that you're trying to protect. So if you go to the next slide.
Well, one thing I want to bring up on this slide too, Scott, is this is from an operator perspective. A lot of people always are looking at the screen of like a traditional AP4C or AP4C plus, and they're seeing the bars of information. Well, the AP4C and the AP4C plus actually are measuring continuously for a exact measurement, and then they apply it to the bars. So if you're using the ProEngine Shield, you're actually going to get the exact measurement that it's doing, not the applied to bars. And so we often will use this when we're doing testing because it allows us to see exactly what the AP4C is seeing and not have you say cluster it into a bar of information. So hopefully that makes sense.
I appreciate that. Yes. And then going back to this example where you're having multiple locations, multiple sensors in multiple locations, and being able to monitor it by linking all those together, you can have that in one central location or more than one location if you so desire, in order to respond appropriately and have people that monitor it. And sometimes, the operational people, so the ones that are actually, the JHAB people that are carrying the detectors, and then sometimes it's also helpful to have another set of eyes or people that are monitoring back and forth that can provide that back office support, that can do those the needed research, that can continue to ask different questions to help to refine the approach. And then obviously from a command and control standpoint, we have limited resources available. We aren't always unlimited. So it's being able to judiciously decide where to respond and how to respond, and then also bring in or call in additional resources if it results to that magnitude in order to properly respond to the situation. So again, these situations are very complex because they involve multiple locations, multiple parties, multiple technologies, and then multiple potential threats, all of which have unique nuances to them. And to be completely able to be prepared for every single scenario is probably not a realistic, but obviously we want to try to be able to protect against as many scenarios, and then the ones that are the curveballs still be able to appropriately respond to them by bringing the necessary tools that are there. So hopefully this was kind of helpful in showing different scenarios or different ways of doing that. Obviously every location and situation is unique. And so what that speaks to is obviously having tools that can adapt to the specific nuances of different environments and still provide the same capability and information profile for that. And that's an additional challenge with some of these events. So again, as far as recommended solutions, as far as a JHAT type of response is the AP4C Plus, that in particular, because that can be man-worn. You can attach it. We have a sleeve with a MOLLE system, so you can attach it right on your body. You can be detecting and having that on, but not really scaring or threatening anyone. But then you can also take it out of the holster and use it to interrogate materials directly to bring that closer where you need to get a close-up response for it. We have we have solutions that do both chemical and biological. They can also be applied on vehicles or some sort of moving cart, or can be fixed if so desired for those. And they are constantly monitoring as well, but provide additional information for it. And then how you tie all those things together. So the advantage of kind of our technology is we have our core technology in a variety of different forms that are used to adapt to different types of scenarios. They all use the basic same principles, but they're applied differently, and they have different form factors as a result of that, based on the processing power or the speed of the air going through the device, or other sort of parameters that need to be done with that. And then just the ability to tie all those disparate things together into a single approach to use for command and control. Next slide. You want to take this one?
I guess it was just more from my perspective, making sure that we know there's not any one solution that can answer everything.
Correct.
And so when we start looking at the layered approach and then look at the threats, so one of the first steps in the entire process is to do the threat assessment and to say, what are the types of threats that we think we may see or could potentially see in each of the rings of the threat matrix? And then try to target your capabilities of what you have to carry into those rings. And when you do that, you could actually come up with a kind of a focused approach to what you should be carrying for each section. And that's going to be really critical. But with that, ProEngine provides things across that whole process. And so we wanted to make sure everybody was aware of that. With that, I want to also make sure we're up to our time, that we do have some webinars coming up, which if you had interest in some of these areas might be interesting to you too. So we're doing one advanced on critical infrastructure protection on the 18th of May, which is a Monday. We have one on drone mounted operations of how do you employ your AP4C Plus on a drone. And then other one on technology integration and how do you do this orthogonal detection approach that we did talk about a bit today, but we'll go into more on December 9th. And so with that, we will follow up with everybody with the review of the video so that everybody can get access to the video if they want to see it again. If you have questions in the meantime, please feel free to reach out to Scott or myself directly. Our emails and our phone numbers are on the screen, and we're both always interested in providing support and answering questions in any way we can. If there aren't any questions, we can hang on for a few minutes. I'm not seeing any right now. Otherwise, if you send them to us directly, we can go ahead and get back with you. So Scott, I think with that, do you have any closing comments?
I don't. Just appreciate everyone attending. And obviously, if you do have a quick question here or there, feel free to reach out and we're here to help.
And yes, one of the questions that just came in is, love to see the presentations again, which is fantastic. And will attendees get alerted to future webinars? Yes, if you got alerted to this webinar, you'll get alerted to future ones. And it's the same process. I have them all set up already in the system. And so we can send you links now to register if you want to get ahead of forgetting and getting it on your calendar. So yeah, please feel free to reach out.
Yeah, and they could send me an email, and we could make sure we can add them to our. We usually send out mailers from that, but we don't automatically sign you up to that. But if you would want it to be added to, we're more than happy to do that.
Okay. Well, again, thank you for taking so much of your time with us this morning, this evening, this afternoon, depending on where you are. Stay safe out there. And again, if there's anything that we can do to assist, please feel free to reach out. Thank you.
Thanks.